In this lesson, we're going to talk about how to solve a linear system algebraically. So if you remember from the previous lesson, a linear system is when you have two or more straight lines. System meaning more than one equation, and linear meaning straight. So let's say we have two lines, right, that intersect. Graphically, we can make pretty easy sense of this because it's the point of intersection, where they intersect, right? But we said this at the end of yesterday's lesson. What if the coordinates they intersect at are decimals or something really difficult to find, or really large numbers? What if they intersect at, 1,000 and negative 893? That's going to be difficult to find on our little graph, right? So what we want to do is do it algebraically, and it's not as difficult as it sounds, okay? So again, what are we doing? Before we did it graphically, we drew the lines, right, to find the point of intersection. That's what we did. It says see above, see yesterday really is what it should say. And algebraically, use the equations to solve for the point of intersection. So that's what we're looking for. What is that point? So keep that in mind. What we need to find in the end, the goal is to find an x coordinate and a y coordinate that these two lines meet at. That is our goal. Let's find that, okay? So here's how we do it. I got the steps written out, and it'll be in your handout if you want to print that out at home. Okay, so let's start by solving this. And I got all the steps written out, so hopefully you can follow along. Now the first thing is we need to rearrange all the equations in a slope y-intercept form. Remember, that's y equals mx plus b form. Okay, so let's check it out. Our first equation, y equals negative 6x plus 21, is totally fine. He's already in y equals mx plus b form. How do I know that? The y is isolated, right? That's the secret. We got to get y isolated. The next one, though, is not. So we need to isolate that. So let's bring him over here and check him out. 6x plus 2y equals 18. So how are we going to isolate that? Well, the 2y is already alone, or is already on this side. So let's just leave that alone. And let's move the 6x over. So how are we going to get rid of 6x from this side? We have to do the opposite by subtracting 6x. But to keep it balanced, recall we have to subtract 6x from both sides. So we end up with the negative 6x on the other side now, plus 18. I'm just going to put it in front so that it kind of follows this pattern where the x term is in front and the b is after, right? Okay, now to get rid of the 2, we have to divide both sides by 2 because our goal is to completely isolate y. So first we get the term with the y in it alone, and then we divide by the coefficient. So negative 6 divided by 2 is negative 3x, and 18 divided by 2 is 9. Okay, so we got our two equations. So here's the two equations I'm going to use. I'm going to use this one, right? Y equals negative 6x plus 21. And I'm going to use the second one that I rearranged, y equals negative 3x plus 9. Okay, so now here's where we got to make a little jump in our thinking. And let me just kind of highlight and talk about this here. So since both equations share the same y value and x value at the point of intersection, what we're going to do is we're going to combine the equations into one. So what we're saying here is, let me just write my two equations out here side by side. Okay, I'm just going to write them up here. One of them is y equals negative 6x plus 21, and the other one is y equals negative 3x plus 9, right? At the point of intersection, these y's have to be the same value, right? And these x's have to be the same value. They have to be the same number. So we're trying to figure out what that number is, right? So here's what we're going to do. Notice how the y is isolated in both cases, right? We have y equals this and y equals this. Well, didn't I just say, don't the two y's have to be equal to each other? These have to be equal, the y's, right? And the x's too, but let's just focus on the y's for now because they're isolated. The x's aren't isolated, right? They're on this side all jumbled up. The y's are nice and alone. So if the value of y has to be equal, and if this y equals this, and this y equals this, therefore, the equation part on the other side also has to be equal. So what we do is we're going to take that equation part, I'm going to highlight it here in blue, we're going to take the equation part on the other side and set them equal to each other. I keep calling it equation part, I should call it the expression on the other side. Okay. So what we're going to do, like I said, one more time, since the y's have to be equal, what y is equal to here and what y is equal to here, therefore must also be equal. So all you got to do is, I'm kind of over-explaining it, but all you got to do is set the two equations equal to each other. So get rid of the y's and set this part equal to each other. So in other words, it doesn't matter which goes on which side. I'll just start with the negative 6x plus 21. Negative 6x plus 21 has to therefore be equal to negative 3x plus 9. Now, why are they equal? Because we're looking for the point where they're the same, where they have the same point of intersection. So we set them equal to each other. So essentially what we've done is we've taken two equations and combined them into a new one, okay? Okay, so now what's the next step? Well, let me just move my page down a little bit here. All right, so the next step is, now that there's only one variable left is x. Do you notice that? There's only an x. The y's are gone, right? So that's the secret. There's only an x left. So what we're going to do is solve for x using our solving skills. So how do we do this? Remember, let's isolate the x on one side of the equation. So let's move all the x terms to one side. So I got the negative 6x. He's already over here, so I'm just going to leave him there. I want to get this negative 3x off of the side. So the opposite would be to add 3x to the other side. Okay. Now, what about on this side? I have the 9 already. I want to get the 21 off of the side, so let's subtract 21. All right, so we've just collected the x's on one side, collected the constants that don't have x's on the other side. Negative 6x plus 3x is negative 3x. 9 minus 21 is negative 12. There we go. And to finish it off, divide both sides by negative 3 to completely isolate the x. And you get x equals 4. Okay, so what we just found, if we think back to our equations again, or think back to our lines, right? Think we have two lines, and I'm just drawing two random lines. These don't really represent these very well. Just two random lines there, right? But the idea is these two now intersect at a point, and the x-coordinate of that point is 4. All we need to do is figure out what's the y-coordinate of that, okay? And it's pretty easy. All we have to do is, and let me just read it here with you. Now that you have the value for x, substitute it into either of the original equations and solve for y. So what do I mean? I'm talking about these guys I have highlighted up here in blue, right? These ones right here. Substitute it into either of them. You don't have to do both, but I'll show you. Watch what happens when we sub it in either of them. We should get the same y value out. All right, so let's start with the first one here. We have y equals negative 6x plus 21. And let's write the other one down here. Y equals negative 3x plus 9. All right, so what I'm going to do is I want to take that x value that we just found, this right here, x equals 4, and what do I get when I sub it into this equation? And what do I get when I substitute it into this equation? I should get the same number if I've done everything right. If I don't get the same number, something's gone wrong. So what's negative 6 times 4 plus 21 compared to what's negative 3 times 4 plus 9? Well, negative 6 times 4 is negative 24, and negative 24 plus 21, we get out negative 3 for y. All right, let's do the same thing here. Let's double check. Well, negative 3 times 4 is negative 12, and negative 12 plus 9 is also negative 3. So that shows me that this point is on both lines. When the x-coordinate is 4, the y-coordinate is negative 3. That would be the point of intersection. So I'm just going to draw my little diagram up here. Again, it's not drawn accurately, but the idea that that's the point of intersection. 4, negative 3. Okay, so that's our solution. That's our point of intersection. That's the answer. We did it without graphing, okay? So you don't actually have to substitute the x value into both equations, but the nice thing about that is if you get the same number out, you probably did everything correctly. So there's our answer. If someone says, what's the solution? The solution is this. There you go. Okay, it's a point. It's an x and y coordinate. So that was our goal, and we found it. All right, so I'm just going to do one more with you really quickly, just to show you to watch out for one other scenario, because everything's basically the same thing. What are the steps? Right, make sure they're both in y equals mx plus b form, set the equations equal to each other, basically cut off the y's and just set the rest of the equations equal, solve for x, and then once you have x, solve for y. It's pretty straightforward. Let me just do one more with you here. Okay, let's just look at one more, example 2 here. I've come up with two random equations. So in this case, I don't think we're going to get such a nice point where the last one, it landed on perfect coordinates. We might get some decimals here, which we prefer to write as fractions. So this guy, first equation here is okay, right? He's in y equals mx plus b form, so no problems there. The second one, though, however, is in standard form, so we need to convert it, right? All right, so how are we going to do that? Well, first, let's just leave the term that has y in it alone. So negative 4y is going to stay where it is. We want to get rid of the 5x from that side by subtracting 5x from both sides. And we want to get rid of positive 8 by subtracting 8, right? But we have to do it to both sides to keep it balanced. All right, now to finish it off, we just divide each term by the coefficient of the y. All right, so negative 4 divided by negative 4 is positive 1. I can cancel these two negatives here and just make it 5 over 4. And negative by negative, again, is positive. And 8 divided by 4 is 2. Oh, I forgot my x in there. There we go. All right, so there's my two equations we're going to use, right? The original one we didn't have to touch, and that one. Okay, so there's step one. We got to make sure both equations are in y equals mx plus b form. Do you remember what step two was? Step two is we're looking for the point of intersection where the y's and x's are the same. So since we have the y's isolated, what the y's are equal to also has to be the same. So what did that mean? Again, I'm just going to do it over here. 3x minus 1, take this portion of the equation, right, what y is equal to, and set it what y is equal to from the other equation, okay? So some call this substitution, some call this comparison method because we're kind of comparing the two equations, right? We basically cut off the y and we set what's left over equal to each other. Okay, so now our job is to isolate x. Now, let's review a trick we learned back in the fall that was really important that would make this a lot easier. Remember see how this guy is being divided by 4, right? When we're solving equations, if we want to eliminate the fractions, remember what we can do? Multiply both sides or every term by that denominator. So that denominator is a 4. Let's multiply each term by 4. 4 times this, 4 times that, 4 times that, and 4 times that, right? I'm going to multiply everything by 4. So what's 4 times 3x? Well, 4 times 3x is 12x. What's 4 times negative 1? Negative 4. Now here's where we got to watch out. What's 4 times 5, right? 4 times 5 is 20, but what's 20 divided by 4? It's 5. So in this case, I just cancel the 4's, right? And we're left with 5x. And finally, what is 4 times 2? It's 8. So we've multiplied everything by 4. But what people get hung up on all the time is they go, no, you didn't. It's still a 5. It was never a 5 to begin with. It was 5 quarters, right? It was 5 divided by 4. Now it's 5 because we've canceled out the 4. That was the whole reason why we multiplied both sides by 4 was to eliminate that divided by 4. All right, so now it's a different number, right? 5 is different than 5 quarters. Okay, so let's collect all our terms on all our x terms on one side. So I'm just going to subtract 5x from this side. Let's collect the constants on the other side by adding 4 to the other side. All right, 12 minus 5, we have 7x. 8 plus 4 is 12, and divide both sides by 7, and you're going to get x equals 12 sevenths. All right, so that's a decimal number, right? If I bring up my calculator here, we're going to get a decimal, right? 12 divided by 7 is, look at it, 1.714, blah, blah, blah. It starts to repeat, but that's a really long decimal. So we don't want to use decimals. We like the fraction better, okay? The fraction is more accurate, and it's easier to work with when we substitute it in to find the y. So now we got to make a choice. We want to substitute this in to one of the two original equations. Now we can do both, but what you do is, remember, you choose an equation, okay, and you substitute it in to solve for y. So who do you want to choose? Do you want to choose this one, or do you want to choose this one? I know which one I'm going to choose. I'm going to choose the first one. It's a lot easier, right? Less fractions, less to work with. So I'm going to choose y equals 3x minus 1. Now what are we going to do? We need to substitute that x equals 12 divided by 7 into that equation. So y equals 3 times 12 divided by 7 minus 1 to solve for y. And this is pretty simple, right? You can't reduce the 3 and the 7, so let's just go, well, 3 times 12 is 36 over 7 minus 1. Okay, we need a common denominator for 7, and this is like 1 over 1, so let's times it by 7, get a common denominator of 7. All right, so we have 36 over 7 minus 7 over 7. What's y equal to? Y equals 36 minus 7 is 29 over 7. Wasn't as bad as it looked, right? To find that fraction. All right, so what's our final answer, right? Well, our solution is, so I'm going to write, therefore, the solution is, remember, it's an x-coordinate. The x-coordinate is 12 over 7, so it's a fraction, right? It's a decimal number. And the y-coordinate is also a fraction, 29 over 7. So this is where algebra is more important than graphing, because graphing, to find out what that exact number is, you're never going to figure out just by drawing it yourself that it was 1 point whatever, right? Getting that decimal. But here we have the exact specific answer, no rounding, nothing, goofy. There you go. So maybe it looks hard, but I did the same thing. What did I do? Step 1, make sure both equations are in y equals mx plus b form. Step 2, come over here. I set the two equations equal to each other and solve for x. Then I came over here and I decided I substitute that into whatever equation looks the easiest to me. You can do both. You should get the same answer, but I just chose this one because it's way easier, right? And I solved and got the y coordinate, and there it is. Okay, so you're finding the x and y coordinate. All right, so give the homework a try and ask questions. Don't wait till the last day. Ask questions, okay? And I'll help you out if you're having any trouble on them.